131 palindrome partitioning. Giving a string S, partition S, such that every substring of the partition is a palindrome. Return all possible palindrome partitioning. So as you see, the string is given to us is AAB, and these two lists are the possible partition of this string, that they are all, every single element is a palindrome. A is a palindrome, A is a palindrome, B, AA is a palindrome. So what is a palindrome? A palindrome is a string that you can read it the same way backward and forward. Let's go through an example and see how we are going to solve this problem. First, let's understand the question clearly. So let's say I have something like this, right? And I want to get all the possible palindrome permutation of this. So one way it could be A, B, A, D, A. This is one solution. Another solution could be A, B, A, D, A. Another solution could be A, B, and ADA. Oh, sorry, ADA. This is another solution, and there might be like a couple of more solutions, but we I think there are no more, but let's say there are more like possible solutions. We are not gonna through this, but like now you have a clear idea about how it works. So let's see how we are going to solve this problem. Let's say this is the example that we have, and we are going to solve the problem based on this example. So let's say we have HYAAB, and we are going to have a result list, which is going to be list of lists. And we are going to add every single permutation that we could make from this list, and it is a valid palindrome. Every single element is a palindrome. We're going to add it to the result. How are we going to do that? We are going to start iterating through this string, and we start from index 1, and I'm going to tell you why. We start from index 1 and we iterate over this string, and every time we check the value, the characters, the string behind this pointer, and if it is a palindrome, we are going to add it to the partial solution that we have. So let's say, is H a palindrome? So this is a for loop, right? So let me write down so we don't forget. This is a for loop that starts from index 1, and we check if H is a palindrome. Yes, H is a palindrome, so I'm gonna add it here. And then what will happen here, that's the most important part. We call this function recursively for the strings from the pointer all the way to the end. So we are going to have a for loop, but this way is gonna be for YAAB. And the pointer is going to point at index 1, and this solution is going to pass down to the next step, so here. And now we check if the string that we have behind this pointer is a palindrome. Is Y a palindrome? Yes, it is a palindrome. I'm going to pass it, write it down here, and I'm going to call this function recursively again. Now this time what we are going to have, so let me write down the for loop here, so it's going to be better and cleaner. So for loop is going to be here, and it's going to point at 1. Oops. And then I will call the recursive function, but this time I have AAB, and the partial solution will be passed down as well. So we have, so far this is what we have, and we are going to have a for loop which starts from index 1, right? It's going to be here. And is A, which we have behind this pointer, a palindrome? Yes, it is a palindrome, so I'm going to add it here, right? And the exact same thing will happen. So now we call this function from the pointer all the way to the end, and the solution that we have from the above recursion function is going to be passed down, right? And then we call, there is a for loop here, for loop which starts from index 1 here, and now we check if A is a palindrome. Yes, it is a palindrome. I'm going to add it here, and the exact same thing, we are going to have B this time, and the solution from the above recursion is going to be passed down. And now we are going to have a for loop, and it's going to point at out of the range. And why we are doing that? Because we want to make sure every single character that we have in the string is included. And we check if B is a palindrome. Yes, it is a palindrome. I'm gonna add it here. Now that we are done with this for loop, we cannot go like more because there are no more strings left. I'm gonna put this solution in here, and what will happen is we are going to return this. And now there's a for loop, right? So now it's pointing at an empty string, which is nothing, and it checks if A and B is a palindrome. Is it a palindrome? No, it's not a palindrome, so it's gonna return from here. And now it checks. We are not gonna have A here. So now the pointer goes to the next one. It checks if A and A is a palindrome. Yes, it is a palindrome, so it's gonna add it here. And then it goes to the so it calls this function recursively just for B, and so on. And then for the next step, what we are going to have after doing another recursion, we are going to have B here. So this is going to be another solution that is going to be added here, and so on. Now that we have a clear idea about how we are going to approach this problem, we start the code. So what I'm going to do, I'm going to have a function that is going to check if it is a palindrome or not. Is palindrome or not, right? I'm going to pass a string to it, and I'm going to say return if s, whatever we have, is equal to s, the recursive one, right? It will return true or false. And then I'm going to have the recursion function. And what does recursion function gets? It gets a string, and it gets the new partition, right? And what it does, it says if length of s is equal to 0, we are going to add the new partition to the results. Right? And we are going to return. Otherwise, we are going to have a for loop which starts in range, as I said, we start from index 1 all the way to the n plus 1, because we want to make sure we get every single character, and we check if is palindrome, right? We call that function, but this is the tricky part. What we are going to do, we are going to say we want to check every single string behind the pointer, right? So it goes all the way to the I, and if it is yes, then we call the recursion function. Recursion, we are going to call it for the string from I all the way to the end, right? And then we are going to say the new partition, which is a list, is going to accept the S all the way to I. And then we need what we need to do, we need to have a results list, which is going to be what we are going to return. Then we call the recursion function, and we pass the string an empty list, and then we return the results at the end. So let's make sure that we have no typos and everything seems partition, new partition, there we go. Everything seems fine to me. Let me clear this so you get a better idea. So there is no indentation problem. Let's run the code. There we go. Thank you.